Hi everyone and welcome to this video on solving differential equations using definite integrals. Before we get stuck into this, what we're going to do is we're going to consider this general situation. So where dy dx is equal to f of x, and we need to find the value of y when x equals b, given that y equals d when x equals a. That sounds a bit scary to begin with, but what we know is that y is equal to the antiderivative of the derivative, so the antiderivative f of x in this case, which when we evaluate that, we should get capital F of x plus c. So that's just notation that we can use for the integral. Now from there, we know that when x equals a, y equals d, so I'm just going to say use the coordinates a and d. And so that means d equals f of a plus c. So usually we would want to find out what c is, so we can sub it back into the equation. So that's what we're going to do. So c equals d minus f of a. Oh, that was a bit weird. Let's just fix that up. And so I can sub that in now and say therefore y is equal to capital F of x plus d minus f of a. But then what we're looking to do is to find the value of y when x equals b. So when x equals b, sub that into the equation and we'll get y equals f of b. Now I'm just going to change the order of this slightly because all we're doing is adding and subtracting, so it shouldn't make much of a difference here. So I might write it as minus f of a and then plus d. And you might recognize this bit right here. So this is just the definite integral. And so I could say that y is equal to the integral between a and b of f of x dx, and then we've still got plus d on the end. And remember that d is this initial condition here. So that's a general rule that we can use. And so if we have a quick look at the example here, for the differential equation, dy dx equals x cubed minus 5, find y when x equals 4, given y equals 1 when x equals 2. Alright, so just making substitutions into the rule there, y equals the integral between 2 and 4 of our function, which is x cubed minus 5 dx. I have to do the plus d, which d in this case is 1. So that's this y condition here. And now it's just a matter of evaluating that. So we're going to get x to the 4 on 4 minus 5x between 2 and 4, and then there's still a plus 1 on the end. So 4 to the power of 4 should be 256. Dividing that by 4, we should get 64. Minus 5 4s. Then take away subbing the 2 in now, so we're going to get 16 on 4, which is just 4. Minus 5 2s. And then still carrying that plus 1 through on the end of the equation. So here we're going to end up with 44 plus 6 plus 1. And so we get 51. And so I could just summarize by saying therefore y equals 51 when x equals 4. So that's quite a nice way to get to the solution. Now we could of course also do this using the calculator. So if we go through how to do that just quickly. I'm just going to solve a differential equation, so dsolve. The equation is going to be y dash equals x cubed minus 5, independent variable x, dependent y, and I'm going to include the initial condition that y of 2 is equal to 1. So there's the rule. I'm just going to bring that down to the next line. And then say given, here it is just under math 3. So given x equals 4. And the answer is 51 as we found. So that's a fairly efficient way to do it using technology. The other question here, so solve dy dx equals 2 sec squared x at x equals pi on 3 given y of 0 is equal to 1. Okay. So first things first, we know that y is equal to the antiderivative of 2 sec squared x dx. And that's going to be between our x values, which in this case are 0 and pi on 3. And then I have to have plus that initial y condition, which is, again, in this case, just going to be 1. So y equals, now the antiderivative of 2 sec squared x should just be 2 tan x between 0 and pi on 3. And then we've still got a plus 1 there. So subbing in our values, we're going to have 2 tan of pi on 3, which is just 2 root 3, minus, and then subbing in our 0, we're going to have 2 times 0, and we've still got a plus 1, and so our final answer is just 2 root 3 plus 1. And again, this could be confirmed using the calculator fairly easily, so if I just do the antiderivative between 0 and pi on 3, of 2 over cos x all squared, and then add 1 onto it, we get our 2 root 3 plus 1. Of course, we could use the differential equation solver again, but either way. So anyway, I think that's about all for this video. What I might also just add though is that, like, there are a number of problems where, you know, it won't be really easy to actually anti-differentiate them, and it's sort of expected that you would use technology in these cases. In particular, you know, I know that there's another example in the book where it goes over the equation of normal distribution, the standard normal distribution, I should say. I think that that's worth a look, but, you know, it's basically just a calculated question. So keep that in mind as you work through, and yeah, we'll leave it there. See you all later.